Okay, we're going to talk about the percent equation today, and probably a little bit more of a review to start. Is actually going to be three things that for some reason trip us up, but shouldn't trip us up. And it's good for you to have a very, very good solid understanding, focusing here. All right, and we're on 3-4 by the way, for those of you that don't know and aren't there yet. It turns out that the rules are simple, but for some reason we find a way to mess everything up. And we don't want to do that, okay? In fact, these are things, while you have questions, while I welcome questions, while I want to help you, this is pretty cut and dry, okay? So let's go over it, all right? First of all, it is, I put a chart together that actually is the first three questions in your lesson. I have P standing for percent, F is a fraction, and D is a decimal, all right? Fractions, decimals, and percent. So whatever it is I give you, you ought to be able to put it back into the others. Our first example is they give us a percent, they want us to put it in a fraction and a decimal. The second one, they give us a fraction, but they want it the other ways, okay? So we're going to, once and for all, help you understand how easy it is to interchange all three. Okay? It's not that hard. Now, when you think about a percent, you always have to think of two words, all right? Over 100. If I say 17%, you know what I'm automatically saying? I'm automatically saying 17 over 100, okay? If I say 83%, all right? If you were talking to the doctor, and the doctor said you had an 84% chance of living through this surgery, would you like that?
No.
You would, all right? Now, why would you like that? Why would you like an 84% odd? Okay, why?
Because it's 84 over 100.
Good, exactly. It's 84 over 100. That means for every 100 people that have this surgery, 84 of them live. Okay? That's pretty good odds. But if the doctor says to you, you've got an 11% chance of making it through the surgery, well, then it looks a little bleak. And we know that because 11 people only live for every 100 surgeries. The odds are not in your favor. Now, you could take that chance, and you could be like, well, we're going to pray and just hope that I'm one of the 11%, okay? But you have to understand, every time we have a percent, it's always what? Over 100. So, a percent to a fraction is as easy can be. We just put it over 100. Now the only thing is it rhymes with, oh, let's see, educe.
Reduce.
And it starts with R. Reduce. So 82 over 100, both numbers in the numerator and denominator are kind of even. So if we just kind of put 82 over 100 over here, if we started cutting them in half, what's half of 82? 41. What's half of 100? 50. Okay? So 41 over 50. Can we reduce that anymore?
No.
We can't. Actually, 41 is a prime number, I believe. So is 43. But just so you know. Okay? So that means 41 over 50 is what our fraction is. That's pretty easy. Now, we could have written 82 over 100. I might have given you a minus 1/2 or something like that for reducing. You need to reduce. And we would know that anyway because the numbers are even. So we can at least cut them in half. Don't leave me numbers like 4/8. Don't leave me 10 over 40. Okay? Don't leave me 80 over 100 if it's 80%. Don't write 50 over 100. Put 1/2. Okay? Please help me out there. Help yourself out. So that means every single time we have a percent, changing it to a fraction is super duper easy. We just put it over 100. Now, sometimes, once in a super duper great while, we get a number that's more than 100. Alright? Let's say we had 99%. We had a 99% chance of living. Well, that's pretty good. 99% chance of dying. That's not good. 100 surgeries, one person lives. The odds probably aren't in your favor. Okay? All right? But let's just say, for example, I had a number that was 115%. Okay? Well, percent still means what? What two, the two roots? Over 100. So what we're going to do is we're going to write as 115 over 100. We actually have an improper fraction. We've got a fraction where the numerator is actually larger than the denominator, and we can actually reduce that if we need to. Obviously, it's divisible by 5. But I'm just illustrating that sometimes a number can be more than 100. We still write it over 100 and reduce. Now, the reality is, as a mixed number, this is 1 and 15 over 100, okay? But we don't want a mixed number here. We want a fraction, even if it's improper, okay? But everything under 100 is not going to be improper. It's going to be a normal decimal, okay? Now, the nice thing about the percent to the decimal is, how many zeros are in 100?
2.
2. So all I got to do is move my decimal over 82, move it over 2 places to the left, and that becomes my decimal. 0.82. Okay? So what's the decimal for 73%? 0.73. Fair enough? What's the decimal for 4%? Because it's a single digit. It's still got to go over, so here's the 4. You move it over 1 is 0.4, which that's not what we want. We move it over again, we fill a 0 in there. So 0.04 would be. All right, how about 117%? We move it over to, good, 1.17, okay? Would be what our decimal is. Got it? Fair enough? Okay, now the second one, oh man, we're given a fraction, okay? Well, we create a decimal by just dividing, right? See, Mr. Graves, but the top number is smaller, okay? Bottom out, remember? Like I said that the first week of school, just kind of reminding you about dividing, all right? It always helps you. The bottom number is always the one that goes out. So 3/5, we put the 5 out and we put a 3 on the inside. Problem is, can 5 go into 3?
No.
No, so we have to add up. We have to add those decimals. We'll put a decimal here, but we're also going to put a decimal up here, all right? So I'll add a 0. 5 goes into 30. Good, 6 times. So our answer is not 6. It's 0.6 for our decimal. Okay, easy enough?
Yes.
Good. Now, watch this. If we're looking back up here, and we see that a decimal is right here, percents go to decimals by moving it over left 2. Decimals go to percents by moving them to the right 2, right? So 0.6 as a decimal, moving the decimal over 2 would be 60%. Fair enough? Good enough? I like that. Easy. Easy peasy. Okay? 1.55. Well, if this decimal went over 2 and we dropped the decimal and made percent, 1.55 would be? Good. 155%. Okay? Now, if percent means what again? Over 100. Looks like we are going to have to come back to this and reduce. We'll take 155 and put it over 100. So 155 over 100. Okay? Well, let's do some math here. We know that they end in 5s. So what's 100 divided by 5? 20. So we know that's 20 there. 155. How many 5s are in there? 31. 31 over 20, right? We just do a simple reduction. We reduce kind of in an opposite way. Even though it's an improper fraction, we can still reduce, okay? So 31 over 20 becomes our fraction. There, 3 plus 1 is 4, so there's nothing that's divisible by 3 at the top and bottom. They don't end in 5 and 0. 31 is an odd number. 31 is also a prime number, which means you can't do anything. So that's what you get, all right? Now, let me help you remember again. Watch this carefully. Listen to me, because this is chock full of your homework, okay? Percents to decimals. Take the decimal point, go left 2. Decimals to percents. Take the decimal, go what?
Right.
Right 2. Fractions. You can do a fraction by just taking the percent and putting it over what? 100 and reducing. Okay? Clear as mud? That's what you got to do. And that's what your homework's chock full of. It's pretty easy to do. Okay? Now let's do these three real quick, all right? This of means what? Multiplier times. Is means equal. And what percent? Percent means what? Over 100. Watch this. What percent, so WP, okay, or I can use X. What percent, what's that mean? Okay, times 85, all right, equals 17. Now we're going to rewrite it so it looks a little bit more professional. 85 WP, and even though it's two letters, let's just make it X, all right? It's the unknown. This should be a dot, so you're not confused. Equals 17, divide both sides by 85, all right? And we get 17 over 85 is what percent of 85 is 17, all right? So, oh, I did that wrong. I did that wrong, sorry. Okay, follow my own rule, all right? What percent of 85, all right? What's percent mean? Over 100, sorry. So I have to take the what percent and have to put it over 100. I knew something was wrong there. But let's make this an X though, okay? X. So X over 100, because this part right here, what percent is the WP over 100, okay? So that means, what's 85 times X? 85X, all right? We can do that. It looks like this on the left side. So we have 85X over 100 equals 17. Okay, basically that's the problem. Do you see that? Okay, clear as mud, right? Okay, we'll get to it in a minute here. All right, how do I get rid of the fraction? I would normally multiply by the what? Denominator. But if I only multiply by the denominator, I'm going to get 85, right? I can actually do one step, and I can multiply and cancel that out and get just X. Okay, what's the reciprocal of 85 over 100? 100 over 85. 100 over 85. Now multiply both sides by 100 over 85. Okay, you see that? So this cancels, what's left? X is equal to, right? 17 over 1 times 100 over 85. So it looks like I've got 1700
over 85.
Right, well I had 17 plus 2 zeros, not 17,000. 1700 divided by 85, and I divide that out and I get my answer, okay? Now for sake of time, that's what ends up happening. We can leave it there as an improper fraction, okay? You got that?
595.
All right, now watch. Okay, look at the next one. What's what? Okay, we don't know what is, do we? All right, X equals 45%. Oh, what's percent mean?
Over 100.
Over 100. We can't write 45, guys. We got to write 100. Wherever the percent is at, we got to write it over 100. Okay? Times what? 236 over 1. Okay? Unknown equals 45 over 100 times 236. Okay? We multiply 45 times 236, and then we divide by 100, which means we just move our decimal. All right? And the answers are in your book. You can see it as example 2. All right? So you understand, you go from there. All right, here's another one. 78, what's is mean? Equals 130%. How do I write that? 130 over 100. All right? But what do I have on the end? What do I have on the end of each fraction?
0.
0. That means I can cancel that out. So really, it's 13 over 10. And I'd rather deal with smaller numbers, right? Okay? Of what number? Which is X. So that means really it's 13/10 X. Okay? How do I obliterate 13/10 and leave X by itself? I multiply both sides by, good, the opposite, or the reciprocal of it, not the opposite, but the reciprocal. The reciprocal means 13/10, so take it times 10/13. Take this times 10/13, all right? And I get 13's cancel, 10's cancel, X is equal to 78 times 10 is 780 over 13. Okay? You see that? So that's what you do. Now, we got this down, all right? And this here, all we got to do is remember this. Of means times, is means equals. For any time you see the percent, put it over 100. If you're looking for the percent, then it's going to be X over 100. Okay? All right, one more time. Percent to decimal, move our decimal over 2 to the what? Left or right?
Right.
Percent to decimal? Left. Okay? Decimal to percent, decimal goes to the right 2. Okay? Our fraction, obviously, is going to be the percent over 100 reduced. Okay? And that's our lesson.